Hi there. So this is our last video in this series. This time we're going to talk about how to conduct an experiment. First, a quick recap of what we talked about in the last couple videos. How do you conduct a study in general? First thing you want to do is frame the question you are trying to answer as a good statistical question. You can't answer the question if you haven't framed it correctly, and you may end up answering a different question than you think you did. Once you've got that question written, you know exactly what you're trying to answer, then you need to pick one of the three major types of studies you can do: a sample survey, an observational study, or an experiment. We've got a whole 20-minute slideshow on sample surveys. Observational studies we're not going to talk about too much, but now let's focus on experimental design for the rest of this. Designing an experiment is really hard to do. It's hard to do well. The first key element of the design is you have to have both a treatment group and a control group. There has to be a treatment group, a group of people who have a set of conditions imposed upon them, and then a control group that does not have those conditions, so we have some point of comparison. An example of why that's important, why it's important to have a control group. Back in the 90s, New York City implemented a tough on crime policy. They hired a ton more cops. They put them everywhere. They focused heavily on petty crime, things like people who would jump the meters in the subway or litter or graffiti, stuff like that. And it was widely hailed as a success. Over the next few years, not only did petty crime drop, which you'd expect, but armed robbery, assault, other major crimes like that dropped as well. Their theory was that the person who jumps over a turnstile today is going to be the person who does an armed robbery tomorrow. Certainly seemed like the policies worked, but there's no control group. They're just looking at New York City. One thing we could use as a control group is other cities, other major cities like Chicago or Los Angeles or San Francisco that did not implement tough on crime policies. And all of those cities also saw significant drops in crime during the 1990s. There must have been some broader effect going on. It wasn't New York City's policies per se. The crime probably would have dropped even without those policies. And in fact, the drop in crime continued even after they changed the policies later on. So you have to have a control group. Otherwise, you don't know whether the effect you're seeing might have happened anyway, even without the interventions you were going to do. Second key element of experimental design is randomization. We want to randomly assign our participants to either the treatment group that gets the treatment or the control group that doesn't. If we're doing it randomly, then the two groups should be identical in every way or close to identical in every way other than which of the two groups did they end up in. If we're not randomly assigning, if we're letting people assign themselves, we're probably doing an observational study. If, for example, you let people choose whether to stay up late or whether to, studying or whether to sleep more, and then you look at the effects of sleeping versus studying, that's an observational study because people made their own selection. Those two groups might not be the same. If you want to look at who earns more money, people who go to top colleges and end up near the bottom of their class, or people who go to less competitive colleges and end up near the top of their class, unless you're going to take people and randomly assign them which college to go to, which you're not because no one's going to agree to that study, then you're doing an observational study, which has a lot more limitations than an experiment. It's harder to say that college is what caused people to earn more or less money because maybe the sort of people who are going to earn more money later in their life would have made one of those choices more often than the other anyway. All right, so here's an example. Just talked about. If I want to see what's more helpful, sleeping or studying, and I let students decide whether they want to sleep or study, then I compare the results. How might that design affect my results? Take a second, turn to your house plant and tell it the answer. Unpause the video when you're ready. Okay, I'm going to assume you paused the video and have now unpaused it. Well, the sort of students who choose to stay up and study are probably not the same as the sort of students who choose to sleep. It's likely that one of those two groups would have gotten higher test scores, even if it was a pop quiz, even if they didn't know the quiz was coming and didn't take any special action, they still probably would have gotten a higher score. I don't know which of those two groups it would be, but it's probably going to influence my results, and it might even influence my results more than the effects of sleeping or studying. All right, another key element of experimental design is that the experiment is blind and ideally double blind. In a blind experiment, the participants do not know which of the two groups they are in. They do not know if they're in the treatment group or if they're in their control group. The problem with that is that sometimes the experimenter, the person they're actually interacting with as part of the experiment, will give off subtle cues they're not even aware of. And the person will pick up on that and pick up on whether or not they're in the experimental group or the control group. A famous example of this was teachers were told that certain of their students were gifted. They didn't tell the students, they didn't convey the information to the students in any way. They just told the teacher, hey, Johnny over there is gifted. At the end of the school year, Johnny was getting higher test scores than the students where the teacher was not told that they were gifted. So the teacher's expectations of Johnny led to Johnny actually getting higher test scores than the other students. And that's pretty common, that the experimenter's expectation of what will happen influences the results. So ideally, the experimenter doesn't know either. They just say, you're in group A. I don't know if that's the treatment or control group. Here, group A is supposed to do this. Go do this. That's all I know. That's a double-blind experiment. That's ideal. Not always possible, but ideal when we can do it. So, for example, if I want to know whether or not watching Khan Academy videos helps prepare students for a test. So half my students are in my treatment group, the other half are in control. The day before the test, I email each student with a link to a video. The treatment group watches a Khan Academy video about the chapter. The control group watches a video on relaxation techniques. Would that be blind, double blind, or neither? Pause it, think about it. Unpause when you're ready. While you're thinking about that one, example 3. Let's say I want to know if imitation vanilla extract tastes the same as real vanilla extract. I have a friend who actually did this study, by the way. It results in a moment. So I baked 2 batches of chocolate cookies, one with imitation vanilla, one with real vanilla. I have my wife randomly label the 2 batches A and B, and she doesn't tell me which are which. So I show up to school with just a batch that says A and a batch that says B. I have my students try them and pick their favorite. Only after they've picked A or B, then I call my wife and say, hey, they picked B, which was it? Is that blind, double blind, or neither? Pause the video, think about it, unpause when you're ready. So example 2 is going to be blind. The students get the video. They don't know if they're the treatment group or the control group, but I know. But since I'm emailing them, I'm probably okay. That probably won't influence them much. Example 3 is double blind. As I'm passing out the cookies, I don't even know which ones are which, unless I somehow marked them when I was baking them, but let's assume not. So that's really ideal. That's a double blind study. I can't influence the students by giving any subtle cues as I'm passing out the cookies as to which ones I think are going to taste better. All right, so putting it together, what's in a good experiment? You've got to have a control group. You've got to randomly assign the participants to the treatment or the control group. Or sometimes you expose all participants to both, and ideally then you expose half to the treatment first and the other half to the control first to balance that out. And ideally the experiment is double blind where the experimenter does not know the results are, but at the very least the experiment should be blind. No participant should know if they're in the treatment or the control group because their knowledge of that will probably influence their response and it'll influence the effectiveness of the experiment. If you meet these 3 conditions, you can be pretty confident that any effect that you see was actually caused by the treatment, as opposed to by what people chose or what they thought was going to happen or their own beliefs. If you don't follow these, then all you'd be able to say is that the treatment and the effect you see are correlated. You'd be able to say they're connected or they're related, but you wouldn't necessarily be able to know that the treatment caused the effect that you're seeing, just that the two seem to happen at the same time. So for example, let's say I want to design an experiment to see what's better, studying all night or sleeping 8 hours. So here's my experimental design for that. I'm going to recruit 100 volunteers, or as many as I can get my hands on. I'm going to spend 1 week teaching 2/3 of them a new topic, and the other 1/3 is going to learn something totally unrelated. So they're part of my control to see how much existing knowledge of this topic there was, even if I hadn't taught them a darn thing. Now, of the 2/3 that learn the new topic, half of them are my treatment group. They go to bed between 9 and 10 with the alarm set for 6 a.m. The other half are kind of my other treatment group. I'm really comparing these two, not so much the control. They're both treatment groups. The other half spend the entire night reviewing what they've learned. I'm going to send out their assignment for what group they're in by text at 9 o'clock at night. So they don't know what group they're in until 9 o'clock at night. And even when they get that text, they don't necessarily know whether that makes them treatment or control. They're just being told what to do. The next day, I test all of my participants on that topic. So that example, this example here, I've got my treatment group, I've got my control group, I'm randomly assigning people to the groups, and it's blind in the sense that the students don't necessarily know whether they're treatment or control. They're just doing what they've been told to do. We'll see what the results are. There's no way I can make it more blind than that. There's no way the student can not know that they're sleeping at night or can not know that they're studying. That's going to happen regardless. So it's the best I can do in that situation. Maybe there's still going to be a problem with that. Maybe people will study and think they will do better because they think studying is helpful, but I can't do anything about that. So it's the best we can do with that circumstance. Pause it here, take a few minutes, consider how you would design an experiment to answer each of these two questions. Unpause it when you're ready. We'll go on to the last two slides. All right. Do ginger supplements help alleviate seasickness? How could you test that? One example, my example, yours may differ. I'd recruit 100 volunteers who suffer from seasickness. I'd randomly assign half to the treatment, half to the control. The treatment group gets a ginger supplement. The control group gets a placebo that looks identical to the ginger supplement. The person who's actually handing them these pills has to not know which one is which. They've just got pill A and pill B that they give to the different people. I'm going to subject them to some nausea-inducing motion, like a boat ride or some other controlled environment that induces nausea. Then I'm going to ask them to rate their seasickness from 1 to 10, and I'll compare the ratings of the two groups. They're identical in every way except for what treatment they actually got. They're even identical in what treatment they think they got and what treatment the experimenter thinks they got. So their interaction with the experimenter should be virtually identical. Any difference in their rating has to be due to the ginger supplement and nothing else. Last example, do people like movies more if they think a critic rated it well? I'm going to show the same movie to 100 volunteers. Again, randomly assign them to treatment or control group. Prior to the film, every volunteer is going to get an article to read. The treatment group is going to read an excellent review of the movie. Well, I should say part of my treatment group will read an excellent review of the movie. Part of my treatment group will read a terrible review. And then my control group will read a totally unrelated article. The person handing out the articles don't know which is which. They're going to hand them out in sealed envelopes. At the end of the movie, everyone's going to rate the movie from 1 to 10, how much they like it. And I can compare the people who read a really good review, the people who read a terrible review, and the people who read a totally unrelated article. The people are just given something to read. They don't know what it is. They don't know the context. So they don't know whether I'm expecting them to like the movie more or less as a result of that. I can't I can't erase the knowledge of what they've actually read. So they probably can make some inferences, and maybe what I'm seeing is what they think the effect is going to be. But that's also kind of the question I'm asking anyway. So there you go. There is how to design a good experiment. Hopefully that's helpful, and best of luck on your assessment this week.